Hello everyone, welcome back to Pyman Tutoring. In this short video we're going to be looking at quadratic optimization questions. Let's begin. In quadratic optimization questions, we're looking to find the vertex of a parabola. Now remember that the quadratic function will either be opening down, as in this case, or could be opening up, as in this case. The maximum point here, we normally give coordinates h and k, and similarly in this case, the minimum point will have coordinates h and k. And those h's and k's appear in the vertex form of the equation, which, if you remember, is y equals a into x minus h all squared plus k. And then this is the case when a is less than 0. On the right-hand side, we have exactly the same formula. Some constant a multiplied by x minus h squared plus k. And in this case, a is greater than 0, which means the parabola opens up. So let's look at a typical problem of optimization. So this is a typical type of problem. At last year's New Year's Eve party, a hotel attracted 60 people by charging $30 per ticket. And this year they want to optimize their revenue. And they've done some studies that have shown that every time they reduce the price by $1.50, they can get 10 extra people to attend. And the question is, what ticket price will actually optimize their revenue? So basically the idea is that something is decreasing by a certain amount and causing something else to increase by a certain amount. In other problems, we'll have something increasing by a certain amount, causing something else to decrease by a certain amount. And we can begin by tabulating this problem to give you an idea of what's going on, and that will help us understand how to construct the algebra. So let's make a table, and I'm going to leave some space to add some additional columns at the end. So let's say we have the price of a ticket, and let's say we have the number of tickets, and then the revenue, we'll call that R, we'll call this N, and we'll call this P. And then we know that the revenue is equal to the price that we sell the tickets for, multiplied by the number of tickets that we sell. So the first data point we're given is that if the price is 30, that we will sell 60 tickets, and that will give us a revenue of $1,800. The next thing we're told is that if we reduce the price by $1.50, so our new price will be 30 minus 1 times $1.50, and that means $28.50. Then the number we sell will be 60 plus 1 times 10, the increase in the number of sales, which gives us 70. And if we multiply those two numbers together, our revenue goes up to $1,995. And we can keep going filling in this table. So the next step would be 30 minus 2 lots of $1.50. So that takes us down to $27. The number of tickets we sell will now be increased by 2 lots of 10. So we will actually sell 80 tickets. And if we multiply 27 and 80, we get 2160. So we can see that the revenue is continuing to climb. Keep filling in the table. Now this is not how you're going to do the problem. This is just to demonstrate how we're going to build a formula to solve this. 2550, the number that we sell will be 3 lots of 10 higher than the original 60 because of the lower price, and so on. 2295. And if you continue with this pattern, I won't fill in the whole table, you will find that once you get up to 7 reductions in the cost of the ticket, so that means your ticket is now at $19.50. The number of people that should show up theoretically would be 60 plus 7 lots of 10, which is 130 people. And your revenue goes all the way up to 2535. And if you go one more step and you reduce the price by 8 lots of $1.50, tickets are now just $18 each. The number of people that show up will be 80 more than the original 60. 140 people, but now when you multiply those two numbers together, you'll see that the revenue has peaked and we're starting to come down the other side of the parabola. So how do we build this into an equation? Well, the thing to notice here, and the reason I've written this table in this format, is that we have this number here increasing by 1, 4, 5, 6, 7, and 8. At the same time, this number is increasing by 1. And so we could introduce a variable x. So if we put that over here in a new column, so in this first row, x would be 0. Second row, x is 1. Third row, x is 2, 3, 4, 5, 6, 7, and 8. And x represents the number of increments, or in this case, decreases in the ticket price. In this particular problem, we're looking at a price decrease, so x represents how many times we have decreased the price. And this allows us to make a formula that is a function of x for the revenue. So we can see that if we want a general expression for the price P, we can say that P as a function of x is simply 30 minus 1.5 lots of x. Because every expression in this P column can be expressed in this form, substituting the value of x in the first column for this x in the formula. So this is a general expression for the price as a function of x. Similarly, we can get a general expression for the number of people attending as a function of x. And we would say that that is equal to the original 60, and this time it's plus 10x. Every time x increases by 1, the number of people attending increases by 10. So this is important. In these questions, the x variable is the number of increases, not the actual increase, but the number of increases. This is the simplest way to build the quadratic formula. So let's see what happens next. So let's just rewrite that. So we've said that the price of the tickets as a function of the number of increments or decrements is $30 minus $1.50 times the number of decreases. The number of people attending as a function of x is the original 60 people that attended plus 10 extra people for every increase or decrease in price. Decrease in this case. And so our revenue as a function of x is the price as a function of x multiplied by the number of people attending as a function of x. And this is where our quadratic will appear. Multiply those two expressions together, and we can see that an x squared term is going to appear when we expand this formula. So let's do that expansion. So we've got 30 times 60 is 1800. That's the original revenue, you remember. 30 times the 10, so we've got plus 300, lots of x, minus 1.5 times 60, so that's minus 90x, and minus 1.5 times 10, so that will be minus 15x squared. So let's just rearrange this to look like a standard form quadratic. Negative 15x squareds. We can combine these two x terms. Gives me positive 210 x's and plus the 1800. So there's my quadratic function. I've got x as the number of price reductions by 150, and I've got the revenue as a function of x. It's got a negative coefficient, so it's doing something like this, and we are trying to find the maximum revenue. So we need to put this into vertex form, and we know how to do that. So the first thing we do is pull out the negative 15 factor from the first two terms. So that's going to leave me with x squared minus 14x's plus 1800. And now inside this bracket, I want to complete the square. I've got a factor of 14 here, so I know that to complete the square I need half of that. So this is going to be x minus 7 squared. This squared term needs to be removed because the negative 7 times a negative 7 will give me a positive 49. So I need to remove that 7 squared in order to keep this value the same as the bracket above. Don't forget the minus 15 outside. and the 1800 remains untouched. And now we're almost in vertex form. I can now write minus 15 x minus 7 squared. That's the first part of my vertex form, and now I'm going to take the negative 15 and multiply it by the negative 7 squared. That gives me positive 735. Add that to the 1800, and I'm left with plus 2535 as my vertex form. So my h value is equal to 7. Remember, this is x minus h, and so therefore h is 7. So I know that the peak occurs when x equals 7, and my k value, which is my actual maximum revenue in this case, is going to be $35 up here on the graph. So that means that if my x value is 7, I'm going to maximize my revenue. Well, what does an x value of 7 mean? X equals 7 means that I reduced the ticket price 7 times. So my ticket price becomes 30 minus 7 lots of $1.50. And that means my ticket price is down at $19.50. So to optimize the number of people attending, they need to reduce their price to $19.50. And at that point, their revenue will be $25.35. And how many people will attend? Well, it'll be going back to this function at the top of the page. We've got that the price is now down to $19.50, and the number of people attending when x is 7 will be 60 plus 70, which is 130. So we got to the same answer that the table gave us. In this case, the table was simpler to construct perhaps, but you need to be able to build these quadratic equations and put them in vertex form so that you can solve more complicated problems. Hope that was helpful. Don't forget to like and subscribe. See you next time. Thanks.